Okay, today we will be discussing interference of light. Mm. When we have a single source of light, like your light bulb, light is uniformly distributed within the medium where that particular source is situated. Right? Suppose we have a single source of light, then obviously you have seen the particular wavefronts. They are spherical in nature, and the particular light of this source, light from this source, that is uniformly distributed within the medium there. But when we have two similar sources of light, instead of a single, we have two similar sources of light, right, which are giving out light waves of same frequency, same phase, or having your same having constant phase difference there, held very close to each other. Then the light is actually light is not distributed uniformly. Light distribution is not uniform. Rather, the light from the two sources, that light waves from the two sources, they get superimposed, and the the light from the two sources that get a redistributed, uh, or this distribution of light that gets modified there. At some points we will get uh, the intensity of maximum value, whereas at other points we will get intensity of minimum value there. Right, this redistribution of light due to two similar coming from two similar sources which are placed very close to each other, right, and uh, forming the intensities of maximum and minimum values at certain points, or some other certain other points there, right, that is called your interference. That is called your interference of light, right. So modification in the distribution of intensity of light due to a superimposition of two light waves traveling in the same direction is called interference. So we can define the modification of intensity light as a result of superposition of two light waves traveling in the same direction is called interference. Interference. Okay. So we will actually get the higher intensity at some points, and the point some points we will get intensity which is having minimum value there, right. Actually, when two waves they meet at a particular meeting at a particular point, they are in same phase. uh, by that we mean that crest of one of the wave that falls on the crest of the other wave, or trough of the one of the wave that falls on the trough of other wave, right. That will form uh, the point with light maximum light intensity, and it is called your constructive interference. So if two waves which, when they meet at a particular point with the same phase, when two waves meet at a point in same phase, that is crest of one wave falls on crest of other wave, or your trough of one of the wave that falls on the trough of the other wave. This light intensity at that point is maximum and is called your constructive interference. Right, but when two waves they meet at a particular point and they are opposite in phase, constructive interference. Next is your when two waves meet at a point opposite in phase, that is crest of one wave falls on trough of other wave. That is your light intensity at that point is minimum and is called destructive interference. So this is how your interference is defined and classified. Right. It was beautifully demonstrated by Young, and the demonstration is named as your Young's double slit experiment. Young's double slit experiment. Right. A scientist named Thomas Young, he demonstrated this phenomena of interference in 1801, and in his experiment he took a source of monochromatic light. He illuminated a slit of width about 1 mm and placed two slits parallel to this single slit there. Both the slits, they were narrow in dimension. They were arranged symmetrically parallel to the slit, and their distance from the slit is 10 centimeters approximately, and the separation between the slits is about 2 mm. And a screen was placed approximately 2 meters away from the slits there. Right, this was the experimental setup. As I discussed here, I will try to draw it starting from slit S, which act as source of monochromatic light here. Light bulb is placed here, right, which incidental light on this particular slit, and the light which is coming out of the slit, that will be of the form of your Huygens wavefronts there. Solid light, that solid line that represent your crest, and the dotted one that represent your trough, right? Right. So a set of your crests and trough, that will be formed. That will be formed like this. Now, approximately at approximately a distance of 10 centimeter, right? Two slits they were placed. Let this be your slit S. At these two slits A and B, they are placed symmetrically parallel to slit S. Right. Now the particular wavefront here, that will be that will split into two different wavefronts here. Crest and symmetrically a trough. Trough is there. Another crest. Another crest here. Trough is here. Another crest is there. Sorry. Trough is here, not crest. Right. Another crest is here. And another crest is here like this. Trough and a crest. This one is your trough again, not crest. Trough again. Right. Another crest. One more crest here. Right. Suppose we are having the screen somewhere here at a distance of 10 meters. And this line that represents your screen here. Let this O be the center of screen. We will be having a crest somewhere here, and a trough somewhere here, a crest here, right? Similarly, we will be having a so it goes like this into the we'll be having a crest somewhere here and a trough and a crest like this, right? So if you try to extend these points where these solid lines they meet with each other, right? And the places where these dotted lines they meet with each other, 1, 2 and 3, sorry, this one, try to join them, it will join like this, right? Similarly we will be having the places of constructive interference where your crest falls on crest, crest falls on crest, right? And the places where crest falls on your trough, right? In these places, right? Let they be represented by points P1 and P2, P1 prime on the downward side, P2 prime on the downward side there, right? Right. Now these particular points, if you see that where crest falls on crest and crest falls on crest there, right? Right, crest falls on crest. These are the points of constructive interference. Constructive interference. Right. So that means your O, P2 and P2 dash. These are points of constructive interference. Points of constructive interference. Interference. Right. These are the points where we will get a maximum, right? Where crest falls on crest and your trough that falls on trough, right? So that your amplitude becomes maximum. Your amplitude becomes maximum, right? Where there are other points also, like your P1 and P1 dash, where your crest that falls on the trough there, right? At points P1 and P1 prime, these are the points of destructive interference. Interference. Here amplitude that becomes minimum. Amplitude becomes minimum. Minimum. Right. Right. So these are the places. These are the points of. These are the points where we will be having your brighter. These points will be brighter. These points will be brighter, and these particular points they will be darker. They will be darker. Right. Here intensity is maximum. These points are bright. Here intensity is minimum. These points are dark. These points are dark there, right? So in this way we will get a pattern of bright and dark fringes, right? Pattern of dark and bright bands there, right? And this pattern is called your interference pattern. interference pattern, right? So at on the screen we will get interference pattern. We get interference pattern of alternate bright and dark bands which are equally spaced from each other, right? So in this way we will get an interference pattern on the screen there, right, which consists of your dark and bright bands there, right? Next is your coherent source of light. Actually, whenever we need to do such an experiment there where we need a monochromatic light there, monochromatic means light of single color, single wavelength, right? Actually we need the source to be coherent also. By coherent here we mean that the light produced by the source, that should be continuous, having same wavelength, same frequency, and should be in phase. There should be in phase, or having your constant phase difference, right? So if we need two sources, they should be the coherent one. So only then we can have a monochromatic light that will produce such fringe this interference pattern there, right? Right. Right. So these sources, these sources of same wavelength, same frequency, same phase, or having constant phase difference, they are called your coherent sources, right? Sometimes this particular question is also asked in the exam there, so you need to be clear about this. Coherent sources, right? So sources of light which are having same wavelength, same frequency, same phase, or constant phase difference. Right? So such sources, these are called your coherent sources, right? A different type of coherent sources, they are being used in different experiments there, right? Four different experiments, a few of them we will be discussing in this particular chapter here. So one of them is your Young's double slit experiment. Young's double slit experiment that we have discussed here, right? Which consists of two different slits, two slits there, A and B, right? And the same light source there, same light, so the light from the same source that has been split into two wavefronts there with the help of two slits, right? Forming two coherent sources. Two slits, they form two coherent sources there, right? Second one is your Lloyd's mirror. Right, in which we will be having a narrower source and its virtual image, right? So light coming from the source and its virtual image, right? Virtual image which is formed due to reflection from a mirror, right? They actually interfere to give an interference pattern there. It is like this. Sorry, we are having a mirror here, right? A source of light is here. Its image is formed within the mirror there somewhere here. That's prime. and its interference pattern that is observed on the screen there. Okay. Uh, Third one is Fresnel's double mirror experiment, right, in which we will be using two virtual images produced from a reflection from two different mirrors, right. This kind of arrangement is actually used there. We will be having two mirrors which are actually placed like this, right. Somewhere here we are having a source S, right, light coming from this that is being reflected from these two mirrors, and the reflected light that interferes and forms a pattern on the screen there, right. And it seems that light is actually, if we extrapolate them in backwards, right, right, so it seems that light is coming from two different sources here, s1 prime, s1 prime and s2 prime there, right. These two are virtual sources there. And fourth one is your Fresnel's biprism, right. In this particular case, the arrangement is like this. We are having a very small angled prism here. Source S is placed somewhere here, right, and light that actually moves straight away from this particular point, and the light coming from light at this particular point that actually reflects like this, that actually moves from the prism like this, and it seems that it is coming from two different sources, two imaginary sources, s1 prime and s2 prime somewhere here. We will be discussing all these in the coming chapter there, right. So all these sources, these are called your coherent sources of light. These are called your coherent. We cannot form coherent sources of light from two we cannot make two different sources as coherent sources of light. The reason being, every uh, atom that will have every material, or every source that will have a material which is having different atoms there, right, right. Although it is made up of the same, if the two bulbs or two sources, they are made up of the same similar material there, still there is a difference between their frequencies or their phases there, right, right. So your sources uh, of same material, two different sources of the same material cannot be used as coherent sources. They're coherent sources of light there, right. Okay, I just stopped this particular topic here. We will be discussing about your conditions for constructive and destructive interference in the next lecture.